Swayam Prabha. Digital India. Educated India.
This is a technique which is not called mass spectroscopy, it is mass spectrometry. Don't call it mass spectroscopy because it doesn't interact with electromagnetic radiation. Nothing to do with electromagnetic radiation, striking a sample and giving a signal and things like that. You had a lecture on the very basics of spectroscopy. What a spectrum means and how it is produced and all that. Okay, good. Mass spectrometry, historically, it was developed by a couple of scientists. J.A. Thomson is one of them, and his student later on took up the job of developing it into a technique. J.J. Thomson was interested in separating neon isotopes by their mass. This is the first example of mass spectrometry. Subsequently developed by Aston and Dempster. Here is the age-old spectrum where mercury plus and mercury 2 plus are recorded. Neon 22 and neon 20 are recorded. This is a photographic film on which they record these things. There was no cathode ray tube or anything to measure and store these things. So every time you take a picture, develop it, and then see whether the thing has done its job or not. These are Nobel Prize winners who contributed to various aspects of mass spectrometry. Quite a number of people worked on mass spectrometry. J.J. Thomson for cathode ray tube. Those scientists also contributed to mass spectrometry and earned credit for their contribution. These are the things you need to develop a mass spectrometer. You need a high vacuum system that is connected to an ionization source. In other words, under vacuum you produce ions. Any mass spectrometry you take, you produce ions in the vacuum, high vacuum. High vacuum, I mean 10 to the power minus 6 to minus 8 millimeter of mercury, which is difficult to maintain actually if you are not having a good electricity supply and so on. Because to start from atmospheric pressure to 10 to the power minus 6 star vacuum is not a joke. Then you have a mass analyzer. It is not like somebody is sitting there and weighing the substance, telling you the mass. Mass is calculated based on the electric field you produce and the magnetic field you produce. I will explain to you in a mathematical formulae and convince. Then you have a detector, which is usually a ion detector source, and the data controller is just a computer to analyze the data. These are the steps involved in mass spectrometry. Vaporization of molecule into gas phase, ionization of molecules into ions, both positive ions as well as negative ions. separation of ion according to their mass to charge ratio, detection of ion. Now it is the M by Z ratio which is being plotted in the mass spectrometry. Let us say we are doing an experiment. I am trying to measure the mass which is 10 to the power 6, a million Dalton. I am just using my imagination to put such a large number. But it is 10,000 and 100,000 are very common these days, where you can measure the protein, which is a very large protein, or a DNA, which is a very large DNA, or a carbohydrate, which is a polysaccharide. Many of these compounds can be analyzed by mass spectrometry. All you have to do is do it under sufficiently acidic conditions so that you protonate it 10,000 times. So 10 to the power 6 minus 10 to the power 4 divided by what is the value there? How much is it? A fraction. Huh? 99. So you need to measure only M by Z of 99 to conclude that you had a 10 to the power 6. Such is the power of the mass spectrometry. You can measure masses 10 to the power 4, 10 to the power 5 without any difficulty. I'll explain to you how it is done. Simple organic molecules, mass spectrometry gives you the mass of the sample, the mass of the molecule. Take the example of dopamine. Dopamine is a neurotransmitter. It is taken by people who have Parkinson's disease, like me. Dopamine has to be taken regularly, and it is a simple mass spectrum of dopamine. The molecular weight is 153. What you see is a small peak at 153 M by Z. So you are plotting relative abundance of the ion to the mass to the charge ratio. These are all assumed to be a monocharged cationic species. So you ionize it into a cation that puts out 153, and then fragment this across here. You get 77 as well as 124. The two fragments that you get. Lavendylyl acetate is a fragrance actually. Molecular weight is 196. It is a protonated form of this molecule that is being recorded. Again, fragmentation produces the fragment ion 137. One can follow the fragmentation pattern and predict the structure of the compound quite easily. Mass spectrometry is very powerful tool. Again, organic chemists heavily use the mass spectrometry in their research. You can go around in the department, there are at least a couple of mass spectrometers. NMR spectrometers is plenty. We are endowed with such a privilege to do research in an organization which is equipped so well. Ionization source. How can you ionize a molecule? You just take an electron out of it. Molecular ion. Electron is removed. You produce a cation radical and detect it. You add an electron, you produce an anion radical, detect it. These are the two ways of detecting ions in the gas phase. Why do we do in the gas phase? Why can't it be done under atmospheric condition? Any idea? If your vacuum is 10 to the power minus 6, what will be the vapor pressure of the compound that you inject into it? It will be very low. You cannot have anything more than 10 to the power minus 6 molar solution. If you put in more substance, the vacuum is going to break. Electron impact ionization mass spectrometry is the most commonly employed mass spectrometry when I was a student. Now it is out of fashion actually. Chemical ionization mass spectrometry. You use a gas along with the sample. The gas is ionized and then it is transferred to the sample. Electrospray ionization mass spectrometry, matrix assisted laser desorption mass spectrometry are the new technique for which Fenn and Tanaka got the Nobel Prize. Field desorption ionization, fast atom bombardment. Here neon atoms are bombarded with the substance. Thermospray ionization mass spectrometry is another technique. Analyzer can be a magnetic sector analyzer or an electric sector analyzer. You produce a charge and send it through one of the analyzers. It is going to take a circular path, and with the right velocity, it will either escape the detector or analyzer or bang against the walls of the analyzer. We will see that in a minute. Quadrupole analyzer is a very compact way of designing something. Again, I will show you the principle behind it. Ion cyclotron resonance analyzer is a very sophisticated research-based. Then you have the hybrid quadrupole top. Quadrupole. These are used for high resolution mass spectrometry. Mass range of up to 5 decimal places you can measure. Detectors are electron multiplier tube. The ions impinge on the electron ionization. electron multiply tube and produce a current, and the current is measured. Look at this picture. This is a calutron mass spectrometer used in Manhattan project for uranium enrichment. Uranium isotopes are separated by mass spectrometry. You have uranium, what is the isotope? 235 and 238. You make the hexafluoride of uranium, and then you can distill the two isotopes. You can use mass spectrometry to separate them. This is what probably is happening in the United States and other places where they beat their drums about nuclear weapons. Just look at the size of it. It is taller than a building. There is a guy standing there. You can see there is a guy standing here doing something. And to assemble such a massive unit is waste of time. You can do better by having an ionization chamber which is glass. Then the magnetic sector here is a really mass spectrometer replica. And today's mass spectrometer just sits in the bench. You can go and see in the department, the instrumentation lab. Very compact, very nice, and highly sensitive. What I mean is, you can use the mass spectrometer with a sample size of femtomolar concentration and analyze it and get the sample analyzed. You don't complain about the sample is not soluble, sir, and things like that. Femtomolar is 10 to the power minus 12 molar. And to analyze such a sample, mass spectrometer is a boon. Mass range and sensitivity plot for various ionization techniques. Look at the mass range for nano electrospray ionization mass spectrometer. 1,000. Sensitivity femtomolar, 10 to the power minus 15 mole. These are never heard of prior to the MALDI and the ESI electrospray ionization mass spectrometry. Electrospray ionization mass spectrometry sensitivity is up to 10 to the power minus 13 moles. You can go up to a mass range of 100,000. This chart is very useful to decide what is the technique you would need to analyze the sample. Suppose if you are working in biology laboratory and a guy comes up with the biomolecule which is a polymer, mass spectrometry is a solution. In fact, the electrospray ionization mass spectrometer and MALDI mass spectrometer is more widely used in biology lab than in chemistry lab, because biopolymers are high molecular weight polymers. Why mass spectrometry? What is big deal about mass spectrometry? This is a big deal about mass spectrometry. Composition of solid state devices, OLED. Let us say you have a plate coated with OLED. How much do you think is substance is present in the coating? Milligram quantities? Microgram? Much less than microgram quantity. They can be analyzed directly by mass spectrometry. Analysis of alkanes in blood. How does the alkane get into the blood? The guy working in petrol bunk is constantly breathing hydrocarbon. and his blood can contain hydrocarbon. Analysis of perfume residues in mother's milk. You spray the perfume on yourself, it penetrates through the skin and reaches the inner part of the body, dissolves in the blood and comes out in the form of a blood sample. That's not nice, because you don't know what goes into the perfume industry in terms of the chemicals they put in the. What kind of clothing the Iceman wore dating back 5,500 years? Is it carbohydrate based or is it protein based? If it is protein based, he was wearing a leather jacket. If it is a carbohydrate based, he is wearing a cellulose based. It's easy to measure using a mass spectrometer. Such a research is a very exciting research. You are going to look at a guy who is 6,000 years old and what clothes he was wearing and things like that. Drug abuse in sports and other areas. Mass spectrometer is a very common equipment in analytical labs. I don't know how many of you watch CSI and FBI and things. The shows, American shows. As soon as the sample comes, they will say, I am going to analyze it with a mass spectrometer. It is available to a layman these days. Detection of counterfeit notes. You take counterfeit note and analyze the dies they use to print the note. The signature, if it is different from the original note, then it is a counterfeit. Identification of explosives from a blast scene and forensic. It goes on. It more detection of adulterant in milk, etc. TLC-MS, detection of organic compounds. Identification of flying pesticides in the air. Medicinal mercury in medieval bones. It just goes on. So mass spectrometry is not a useless technique. It is a technique that can take you 10 to the power minus 15 moles down to 10 to the power 6 m by z value. And no other technique is so sensitive as mass spectrometry. The morning I said the NMR is the least sensitive of the spectrometry techniques. Now look at the jump. It is the best in terms of sensitivity. This is a book from which I took some material. Mass spectrometry by Jürgen Gauss. He is an expert in mass spectrometer. Electron beam of 70 electron volts, energy is used. How do you produce a 70 electron volt electron beam? You just accelerate between two poles, pieces of an electric field. Most organic compounds ionization potential is 10 to 15 electron volts. So 70 electron volts is just too much to put in, and it will tear the molecule apart. That is what happens most of the time. A sample is taken 10 to the power minus 2 torr. It goes through a chamber which is ionization chamber 10 to the power minus 7 torr. And the electron beam is the blue dots that you see. The electron beam ionizes the sample, and there are two plates kept here, one in positive potential, the other one negative potential. The positive potential allows the negative ions to pass through, and the negative potential allows the positive ion to pass through. Normally it is a positive ion which is passed through the analysis chamber. The analyzing chamber, it takes a circular path to go to the detector, and only when the curvature of the ion beam is appropriate for this dimension of the spectrometer, it will reach the detector. Otherwise it will hit the sides of the wall and die. After the production of the ions, they are accelerated by an application of voltage potential V. If Z is a charge on the ion, then PV potential energy is equal to ZV. It is converted into kinetic energy of the ion, which is half mv square. The magnetic field of analyzer, they are drawn into circular motion by the field. At equilibrium, the centrifugal force and centripetal force have to match each other. Unless they match, they go and hit the walls of the analyzer. So this equation essentially tells you the m by z value is equal to B square. B is the magnetic field that is applied. R square is the radius of the curvature of the instrument. V is the voltage that is applied across the acceleration zone. Essentially, this is a constant. This is a constant. This you vary and scan across the various m by z value. This is applicable only to electron ionization mass spectrometer. The excess kinetic energy imparted on the molecule during electron ionization process leads to extensive fragmentation of the molecular ion. Fragmentation is useful because it allows you to analyze the molecular structure of the compound. This is a limitation of the technique. You can't analyze a very high molecular weight and very non-volatile compound. The compound has to come to gas phase for getting ionized. If it doesn't, then it will not work. So, two important messages. Mass spectrometer is done under high vacuum. A small quantity of the substance is analyzed, and it's a destructive analysis. You don't retrieve the sample back. 10 to the power minus 15 mole, who cares whether the sample is recovered or not? Chemical ionization mass spectrometry, instead of directly ionizing your substance, you ionize the gas along with the substance, and the gas molecule ion transfers the proton to your compound. Methane as a carrier gas, for example, as a reagent gas, this is taken in a sufficiently large concentration so that in the gas phase there is more of methane than your compound. It fragments into an ion and electron. It loses a hydrogen atom. CH5 plus is produced. What is CH5 plus? What is CH4? What is CH4 plus plus H plus? It is a conjugate acid of methane. The conjugate acid of methane is a very strong acid that can protonate everything in the scheme of things. HCH5 plus is a very strong acid and it is capable of protonating substrates. That is important. But you still need to bring everything into the gas phase before you can do this. ammonia as a carrier gas. Why doesn't it give NH3 minus here when you take an electron and bombard it with ammonia? What is the reason? The substance under analysis is protonated and it gives SH plus, which is recorded in the isobutane as a carrier gas. These are the chemistry that can go on in the gas phase. Look at the spectrum of levandulyl acetate. The monoprotonated species gives a peak at 197.5. When you do it with the isobutane as an ionizer, it gives a tall peak. The tallest peak in the spectrum is known as the base peak. 100% abundance. This is using ammonia as a carrier gas. Ammonium ion is added to 197. What is 197 plus ammonium ion? You know how to calculate? What is the value? How much is it? Chemical ionization mass spectrum examples. Glucose. It's not easy to ionize glucose. It's not a volatile liquid, it's a solid with a high polymeric structure. That nicely ionizes it. Ammonium ion is added to it and it is a peak corresponding to the. This I already mentioned. Nitrogen rule, if you have one nitrogen, the mass will be odd because the nitrogen valency is 3. So 3 hydrogens will 3 point something, it's an odd mass. Carbon 12 scale, if you take, then the residual mass of the various ions is given here. Carbon 12 scale is what is used for calibrating the mass spectrometer. Mass of nitrogen, carbon monoxide and ethylene, they are one and the same. How do we distinguish them? You go to high resolution mass spectrometer, calculate the molecular weight including the precision molecular weight. Now they are distinctly different. So you will be able to distinguish. Similarly, if we take C6H12, C5H8O, C4H8N2, there are various samples, but all of them have a molecular weight of 84. The high resolution mass tells you which is which. If suppose high resolution mass, this is the compound you are getting, that is corresponding to the molecular formula. So elemental analysis is done easily. The difference between the three compounds that is mentioned is elemental analysis, right? Elemental composition is different, that's all. You are recording mass spectrometer. Carbon 12 is 99.9%. The remaining 1% is carbon 13. That should show up in the spectrum. The M plus 1 peak corresponds to that. Elemental composition, some more examples are given here. C60, Buckminster fullerene. 720 is C60, C12. What is the probability of these three species in the sample of Buckminster fullerene? Any idea? How much will this be? 99%. How much this is going to be? This is going to be almost absent. One can analyze that and get a spectrum corresponding to molecular ion peak 720, 721, which is a carbon 13 substituted, natural abundance carbon 13 substituted. Halogen isotopes are very easily detected by mass spectrometry. Chlorine has isotope 35 and 37, the ratio of 3:1. Bromine has an isotope of 79 and 81 in the ratio of 1:1. Mass spectrometer will reflect this very nicely. Look at the composition, elemental composition and the mass ratio of the various peaks. This is a mass spectrum of bromobenzene. Bromine 79 and 81 are there. Look at the peak at 77 is phenyl radical. bromostyrene, dibromoaniline. There is a triplet. What are the peaks due to? Bromine 79, bromine 80, bromine 81 in the appropriate ratio. Dibromo derivative. The M plus ion is given here on the top. What did they do? Oh, it's back. When they sell this equipment, they don't give you a detailed instruction manual. They give a website address and ask you to go there and look up. So the number of features in this kind of a gadget is enormous actually. You can connect a USB, you can connect your computer, you can connect your child. Anything is possible. If you buy this gadget and put it in the living room, the first thing the child would come and do is just bang on the screen. The screen will come up immediately. It's an interesting concept. You should check it out. How much time do I have? Huh? How much time do I have? Don't tell lies. Electrospray ionization mass spectrometry, I will just orally tell you what it is. You make a sample in a solvent and spray it into a very fine spray such that the particle that you produce are micron or less size. And this is a solvent with the sample dispersed in it, and it has come to the gas phase in the form of a fine droplet. The droplet slowly evaporates and gets rid of the solvent around it. At some point of time, the ion concentration is so much, it will just burst open into another fine spray of. This is electrospray ionization mass spectrometer. And ionization is usually done by protonation. You have sufficient proton in the sample to protonate your sample, and the protonated form is what is recorded in the matrix assisted laser desorption ionization mass spectrometry. Is you make up a sample with a matrix. The matrix is usually an organic acid, benzoic acid or cinnamic acid kind of acid. Mix it with your sample and bombard it with a laser beam. Whatever spurts out of the laser beam is analyzed in the mass spectrometer. Very important technique. Maybe I can show one spectrum of high molecular weight compound. Look at the polypeptide molecule that is shown here, cyclosporine. It is an immunosuppressant. People are given cyclosporine when they undergo surgery so that they are immune to diseases. The molecular weight is 1202. The molecular ion plus proton is seen as 1203. This is impossible to analyze by electron impact ionization mass spectrometer. You have to use only small d or ESI. With that, I would like to conclude and thank you for your kind attention. I am not as funny as Srinivasan Star, who took class in the morning. That kind of a humor is difficult to replicate. I normally stick to my lecture and hope a few students will benefit out of this kind of a lecture. You want to thank me? Go ahead. Knock yourself out. If you have a doubt, if you don't want to ask now, you can ask later also. I am sitting downstairs in the ground floor, room number 150B, right next to the elevator. Yeah.
Sir, on the behalf of all the students in RSAC, I would like to express the gratitude towards you for spending your time in teaching us various concepts related to nuclear magnetic resonance spectroscopy, how it works, the theory behind it, and the spiral states between spin states between the atoms, and the chemical shift, and the coupling between the atoms. And in the second lecture, you taught us about the mass spectroscopy, types of it, applications of
Mass
it, and
spectrometry.
Spectrometry.
It is a sin to call it a spectroscopy.
Sorry, sir. Mass spectrometry, various applications, and its aspects of it. Once again, thank you, sir.
Thank you. What is your name?